This is our video for lesson 2.5, and this is solving compound inequalities. So our first question is, what does compound mean? You may have heard of compound words or compound sentences or compound, I think we talk about compounds in chemistry. But either way, this is a putting together of things or something that's made up of multiple parts. And so in this section, we're going to be looking at inequalities that are made up of different parts. And they're going to use these couple of different words to determine how those parts fit together. So we might have one inequality and another one, or we may have one equality or another one. And so we want to think real quickly about what those words mean. If we think about, so if I were to say, so if I was talking about apples and oranges, I'm thinking about the two of them being together, right? If I'm talking about, I have a bowl of apples and oranges. If I'm thinking about or, so think about I've got some apples or I've got some oranges, that means one or the other. So I've got two separate things. And that might be the best way for us to think about this and or. So if we are using the word and, that means both or together. And if we use the word or, that means we're talking about separate. So let's just jump in and look at a couple examples. So we are going to be writing the inequalities and graphing. So part A number x is greater than -8 and less than or equal to -4. So that means it's both of these things together, right? It is bigger than -8 and it is less than or equal to 4. So if I was going to write x is greater than -8, I would write it like this: x is greater than -8. And then my next part is x is less than or equal to 4. Well, normally we would write that like this: x is less than or equal to 4. Well, I want to write those together, and if I'm writing them together, then I'm going to write that with the x in the middle, and we can write this as one statement, right? If we're doing and, we're writing it together. So there's actually two different ways that I can do this. So I can start with my first one. So I've got the x is greater than -8, and now I can add into that x is less than or equal to -4. And so in order to do that, I would need to make sure that x is smaller than or equal to 4. So notice if we look at that from this position right here, we see that that value x, since it's on the small side of our symbol, that means it is smaller than or equal to 4. And we could also write it down here as well. I've already got in this one, I've got the x is less than or equal to 4. And then I could add on the x is greater than -8. Okay, so notice I could write this in either direction and it ends up meaning the same thing. So it's tougher in this case to just kind of read left to right like we learned before. You really need to pay attention to the symbols, which way they're pointed and what that means, right? We need to remember that the open side, the big side of the symbol, means that this thing is larger, and then the smaller side of the symbol means that the thing on that side is smaller. So when we graph this, we've got our number line. I'm just going to put the smaller number to the left, which would be -8, the larger number to the right. And notice that x is between them in this and case, right? X is, for me, it makes more sense to read this one because I've actually got the smaller number on the left. X is going to be bigger than that -8 and less than or equal to that 4. So the graph would look like this. I've got an open circle on the 8, closed circle on the 4, and my solution set is everything in between. So in other words, any of these values in between would make our expression true. Or our inequality, rather. Our inequality true. Part B, y is at most 0. So we need to remember what that means. When we say at most, that means this is as big as it could be. Okay, y is at most 0. It's no more than 0. 0 is as big as it could be. In other words, y is going to be less than or equal to 0. 0 is as big as it could be. Or y is at least 3 over 2, which is the same as 1.5, 1.5. So if y is at least this big, that means this is as small as it would be, and it could also be anything larger. Okay, so or y is greater than or equal to 3/2. So now when we graph this, we can still graph this, even though we've got two separates, because we've got an or. I can still put my 0 on here, and I can put my 3 over 2. But now, notice our graph. If y is less than 0, that means we're shading this way. And if y is greater than or equal to 3/2, we're shading this way. Okay, so we've got or equal to on both. So I've got one going like this, and then the other one is going like this. Next, we can solve when we have these compound inequalities as well. So in this case, I'm just going to rewrite because it makes it easier for me to show my work. X minus 2 and then 3. So if we think about this, so kind of ignore these sides for just a minute and think about what would I do in a normal equation, or if I was trying to get x by itself. So if I was trying to get x by itself, I would have to add 2 to make that go away in an equation. And we're going to treat this just like an equation or an inequality like we've always done. But now we've got 2 inequalities. So we kind of have 3 parts, not kind of, we have 3 separate parts of this compound inequality. So if I add 2 to this part, I have to add 2 to all 3 parts. Okay, so instead of just having one equal sign or one inequality, we can think of this as 3 separate parts. I think I might have made those lines a little bit long because I'm going to run out of room to graph here. So just tidy this up a little bit. So working from the left, -4 plus 2 is -2. My symbols don't change. I've done nothing to make them change. And there we are. I'm down to x. I've got my compound inequality. We can graph this. X is larger than -2 and smaller than 5, not equal to either one. So we can fill in here. Next, we've got a multi-step. Same thing though. We've got multi-step inequality here, -3, -2x plus 1, less than or equal to 9. So again, if we just think about this and what I would do to get that x value by itself, I would want to get rid of this plus 1 first. So I'm going to do that by subtracting 1. And remember, I've got these 3 separate parts now, so I've got to do it to all 3 of the parts, not 2 minus 1, minus 1. And so we end up with -4 is less than -2x, which is less than or equal to 8. Now, final step, -2x, remember, means -2 times x. So to undo that, we are going to divide by -2. If I do it to one piece, I have to do it to all 3 pieces. Okay? Remember, this is only because they're separated by inequalities. So now when I divide by -2 on the left, -4 divided by -2 is +2. Since I divided by a negative, I have to flip my sign, flip my other sign. 8 divided by -2 is -4. Okay, so it's all the rules we've applied before. Everything is still the same. We just have compound inequality. We have more than one together at the same time. If I were to graph this, -4 is my smaller value, so that should go on the left. 2 is my larger value. And where am I graphing? My x value is smaller than 2, and my x value is larger than or equal to -4. So that's going to get it closed. That gets an open circle. And my solutions are everything in between. So in other words, if I picked any number in here between -4 and 2, including -4, but not including 2, if I were to plug that value in here, the entire thing would be true. Okay, moving on to our final example. This is just two separate inequalities. So we have 1, 2. Okay, so this is exactly what we've done before. We're just doing 2 at a time, and we can graph both solutions on one line. So this is a place where I would recommend maybe pausing and just trying to do this on your own, and then coming back to check your work. So let's solve this inequality on the left first. Trying to get y by itself, so I'm going to add 5 to both sides. You end up with 3y is less than -3. And then our final step is going to be divide both sides by 3. And you get y is less than -1. Or we've got the other one. Get y by itself over here. I'm going to add 1 to both sides. 2y is greater than 6. Divide by 2. And you get y is greater than 3. Okay, so both of these are solutions, right? Because I have this or that. So let's draw a graph. My smaller value is -1. My larger value, move this up so I can actually make this look good. My larger value is 3. So I've got y is less than -1. That's going to be this way. And y is greater than 3, that's going to be this way. Okay. Both of these are going to be open circles. And there we go.